in 5, 4, 3, 2.
Hi, my name is Lori, and welcome to Exploring Hobbies. And today we have with us Stan Wilhelms, who's going to talk about mineralogy. Hi, Stan. Welcome.
Hi. Good afternoon.
So tell us about mineralogy.
Well, that's kind of a large subject. Actually, it's a subdivision of a larger one, geology, which makes up earth sciences. So mineralogy is the study of that section of mineralogy, which is minerals are naturally formed, inorganic. They're not alive or have anything to do with the life process. So they're naturally formed, inorganic, with a definite crystal structure and a definite chemical formula.
Wow. Well, how did you get started in mineralogy?
Well, actually, I was following my wife around as she went into shell shops.
Oh.
She grew up in a beach and was interested in shells, and so she continued that interest later on. And in one of the shell shops that we went into one time was this lovely section on minerals. And so while she was looking at shells, I started looking at the minerals.
Wow.
Some beautiful green, beautiful green mineral, which was my first purchase actually, called dioptase. Looks just like an emerald, and that got me going.
Wow. Wow. Well, what do mineralogy do as a hobby? What do you...
Well, we do anything we can do to enjoy minerals. So that might, for example, start with going on a field trip and collecting some minerals.
Okay.
There are a lot of places, and there's rocks all over the place, and minerals are a part of those. And so a lot of places you can go and collect. Unfortunately, in our modern age, we're restricted from many of those places because legal concerns, the quarry is concerned you'll go in there and get hurt. And they don't like being sued, and so
Yes.
you're better off usually, but you can still do a lot of things individually, but better off usually going with a group. So for example, the organization I belong to, the Michigan Mineralogical Society, organizes field trips. And they've got permission from the quarry owner, and you go in there as a group, and you're able to collect that way. So that's a lot of fun.
Okay.
In addition to that, though, since none of us are able to go all over the world, we'd love to go and find all the things that exist everywhere. But so those minerals are brought in by dealers, and they'll take them to a show. And so, again, speaking of the Michigan Mineralogical Society, we have our annual show in October. This year it's the 10th through the 12th. And at that show, we have dealers from all over the world, and you can buy from them.
Wow.
And in addition to things like that, they have displays, like from the Smithsonian. The Smithsonian will have a display there, and Carnegie from Pittsburgh will have a display there, and the Royal Ontario Museum will have a display there. So you see all sorts of wonderful things that way.
Wow.
So even though you might not be able to own them, you can see them.
You can see them. Wow, that sounds great.
Yeah.
Well, what types of tools would you use to get your rocks?
Your
and
hammer and
minerals?
chisel are your primary tools for breaking open rocks and things like that. I have a magnifying glass here. It's another tool that is useful to use to be able to see more carefully into something, what's going on. And then I have a little bottle of acid here for calcite type minerals. Calcite is a carbonate, calcium carbonate's the formula. To really be able to determine whether something is calcite or not, you just have to put a couple of drops of hydrochloric acid on it. And if it's calcite, it'll fizz quite remarkably. And if it's not calcite, then it won't fizz. And if it's something not quite pure calcite, like limestone, for example, is a lot of calcite in it, it'll fizz moderately. So this is a very useful tool for determining a lot of different things. Then another tool is a unglazed porcelain piece of something so that you can scratch your mineral on it. And some minerals will, all minerals will scratch a particular color. Most of the colors aren't that definite, so they're not so clear, but some of them are very definite. So like hematite, for example, will give you a good red color. And so you can determine a lot of them that way. Another tool is a hardness set. All minerals have a hardness. Hardness was a term invented 200 years ago, actually, by a fellow named Moe. And so we have a Mohs hardness scale. And everything goes from 1 to 10, 1 talc and 10 diamond. So diamond is the hardest, talc's in between, and then quartz is like 7, and quartz is the most common mineral out there. And so if you have a kit that will help you determine what the hardness is, so quartz is one of the pieces you'll use in your kit, it will scratch everything that is softer than quartz. So if you're able to scratch something, you know it's softer than quartz, it's one of those. If you use your fingernail, for example, your fingernail's got a hardness of 2.5, and so it'll scratch things with hardnesses of 1 and 2. So gypsum is 2, and gypsum is relatively common and an interesting mineral, and so if you can scratch it, it lets you know you're probably dealing with something like gypsum. An old copper coin, if you have an old penny from years ago, that has a hardness of around 3.5 or so. And so that'll help you determine calcite. And calcite has a hardness of 3. Here's calcite here. So that's very useful. A hardness set is very useful. And it's interesting, while we're on hardness, I just want to mention that quartz is kind of your basic divider.
Okay.
Everything as hard as quartz or harder is a gemstone.
Oh.
And so most of us are interested in gemstone. That's how we got involved in mineralogy. Actually, back thousands of years ago, people are interested in these hard stones that they made into gems. And so quartz is 7, diamond is 10, rubies are 9, topaz is 8, tourmaline is 7.5, so that, and garnet over here is another 7.5, so that it helps you decide where your gemstones are, which is what a lot of us are interested in.
Now, when you go out and looking for these gems, is the outside like rough or covered with dirt?
Well, like this one
I mean, they're
here.
not just brightly, you know.
Oh, no, yeah, no, it's in a rock.
Okay.
And sometimes what you do is you got this rock and you hope there's something in it, so you'll take your sledgehammer and you go whump on the rock. And it'll break open and it'll reveal this little bug that's in there.
Wow.
And so in this one, for example, the yellow stuff is sulfur and the blue is celestite. This came from maybe Michigan, down around Monroe, not too far from here. And actually, it's my most favorite self-collected piece. I actually got this one out of the ground. Most of the time, I'm not able to have the opportunity of doing it, but so this one's got sulfur and celestite. So.
And I noticed this one too has a coating, it looks like, on it. So when you found this one?
Well, that's not much as a coating. Is this what this was in? So again, if you're going to have, this will have to be on the surface of something. This is not likely to be. So if you have a vug or a cave-like kind of situation, this will be in the wall, and you'll break this off from the wall here, and these will be the crystals you're trying to preserve. So these are crystals of calcite, and inside of them, I don't know if you can see the red in there. That's copper.
Oh, wow!
So this is from the Upper Peninsula.
Oh my gosh!
In Michigan.
In Michigan. Wow. Very interesting. So how do you know if something is authentic?
Well, if you've looked at 4 million of them, you've got you get an idea. So it's like anything experience. It's the more you look at them, the more you're able to tell them apart, and the more you learn about them, you're able to determine their specific characteristics.
Wow. Now, did you find all of these?
No, this is the only one here that I found.
Uh-huh.
The others I all purchased.
Yeah. Okay. Very nice. How expensive is this hobby?
Well, it can get as expensive as you'd like it to be. So
with diamonds, yes.
You can go from, a diamond, a good example. You can go from very inexpensive, like doing it yourself, or buying it at a show, like this particular piece here, this pyrite octahedron. I doubt it was more than a couple of dollars.
Oh, okay.
On the other hand, you can spend a lot more money, and some people have collections worth millions of dollars.
Wow.
And the Smithsonian, of course, has a collection worth many millions of dollars. So they can get quite expensive.
Wow.
The more perfect the piece is, the more expensive it will be.
Wow.
So the more it represents how good the piece can be, the cost goes up. And then the bigger it is, generally speaking, the cost goes up. So this cube of pyrite, for example, pyrite, its natural form is cubic. And so this is a natural occurring piece. And it's extremely large, and therefore very unusual. And so this one's pretty expensive. This was a couple $1,000s.
Oh,
I think.
wow.
Yeah.
Is it heavy? Can I?
That's what I said. Yeah, pyrite.
Oh, wow,
made
that
up
is.
of-
I didn't
of-
expect it to be that
Well,
heavy.
iron is its primary
Wow.
component. Iron sulfide's the formula.
And it came just like this? Nobody had a...
No, all we did was clean it.
Oh, my goodness.
And that's what experience, again, will tell you. You can look at it and you can tell whether it's a natural surface or not.
Wow.
Because if it's not, then it's not nearly as good.
Wow.
If it's been altered in any way, the price goes way down. So pyrite, because it's formed in this cubic nature, it's not a perfect cube, and so some surfaces are etched a little bit. You can see little lines running across it that are perpendicular to these.
Right.
And so
Wow.
that makes it pyrite.
And where would you find something like that?
That came from Spain. Pyrite, on the other hand, is one of the more common minerals in the world. Michigan has pyrite. Almost everywhere has pyrite. Because again, it's got iron in it, and iron is very common on the Earth's surface.
Wow. Wow. And this one, where would you find this one?
Well, calcite, that one's from Iceland. Calcite is probably even more common than pyrite, so it's found everywhere also.
Oh, wow.
That came from Iceland. The particular ones from Iceland more commonly have this characteristics where they're so clear like that, and the surfaces, well, because, if I can digress, the light rays, when it hits anything, like if it hits a pane of glass, will go right through it.
Wow.
Well, if it hits water, what happens is, here's your surface of water, light
Right.
hits it, and then it bends.
Oh.
So that when you're looking in a lake or something like that, and you see something on the bottom, and you want to reach for it, it won't be where you're reaching for, because the light ray is bent, and so it's not exactly where you think it is.
Oh, my goodness.
So when things like calcite, the light ray breaks in two, which is an even different thing. So the light ray will come here, and one of it part will be bent a certain angle, and another part will be bent another angle. And so then that allows you to see two things. So when I put this on top of this written thing, and you look down it,
You can see it.
and we can
read it.
have a look at it, you can see how the light ray has bent that.
The
And so
double
now
image,
instead
yep.
of seeing one thing of that,
One.
you'll see two of it, at
Double
least.
image. Wow.
Yeah.
Wow. Well, now tell us about this one. This is beautiful.
That one's tourmaline.
Wow.
Which is the group name for it. Specifically, the species name is elbite. I digress again here. There are about 4,700 different species or different kinds of minerals. And they're discovering more all the time, the more they do. But the ones they discover these days are all complicated formulas, very complex, because all the
Right.
easy ones have been found already. So tourmaline is relatively complex, but not too bad. And it has the variety of this is a Rhodochrosite, and found in Madagascar. And the interesting thing about this, let me hold up this behind it here so you can see it better, is that
yeah.
you can see
That is
the triangular
beautiful.
nature of the crystal.
Yeah.
You see all the triangles in
Yeah.
there? Because tourmaline in its basic configuration is triangular, or trigonal we call it, for three. And so so they slice it open so you can see it better. So that's what that is.
And you said Madagascar that you find
That
this.
one's from Madagascar. Tourmaline's from Michigan too.
Wow. Hardness.
Hardness is
Hardness. What
8.
would the wow.
So it's a gemstone.
That's okay.
It's a gemstone.
Yeah.
Yeah.
Yeah. And I think this one's my favorite.
Okay.
I like this one. What's this one?
Well, that's an agate from the Upper Peninsula.
Okay.
The Upper Peninsula has a lot of agate. Lake Superior agates are world famous.
Yeah.
And you can see the nature here. They call that a fortification agate, because it's like a fort built up with all the structures around it to protect what's on the inside, so-called. Anyway, that's a very nice one. So that's a Lake Superior agate. It hasn't been polished or anything
Wow.
else.
And then this is the outside. This is how it looks
That's how,
when you
yeah,
find it.
yeah.
And then you open it up or slice it or whatever.
Yeah, well, that wasn't even sliced.
No, it was just
whether
like this.
somebody did a sledgehammer to it and it broke,
Oh,
or whether it was
okay.
just found that way.
Oh.
Because nature creates, because in mountain building and all that kind of stuff, there's huge amounts of pressure that occurs. Mountains are raising up and things are being pushed over this and pushed over that. And agates will be forming, let's say, 1,000 feet below the surface. So that there's a lot of pressure and a lot of temperature. It's warm down there underneath the surface. Further down you go, the hotter it gets. And so as the earth is moving, it can break the structure itself. So that could be just the way it was found.
Oh, wow.
And of course, it might have been 1,000 feet or more underneath when it was formed. But as time goes by and the whole Earth was raising up in that area in the Upper Peninsula about 1 billion years ago, it comes to the surface. And then the glaciers will also clear off hundreds of feet sometimes of the surface, dirt and rock and so on, and it'll be at the surface. So this might have been found at the surface somewhere, I'm not really sure.
Wow, that's beautiful.
I got it from somebody
I like it.
who had it in their garage
Oh my gosh.
for the last 50 years, and he died, unfortunately, and his daughter didn't want it, and so she said, if you'll clean out my garage, you can have what's
Oh
there. And
my
so I was
gosh.
very pleased to do that.
Wow, wow. And what about this one? I like that one.
Well, that's quartz.
That is beautiful.
Quartz, again, is your most common mineral found out there. Now, quartz, now we were talking about crystal structure before as one of the parts of the definition of a mineral. And there are 7 different crystal systems. So that on an atomic scale level, the forces within the atom of the components of whatever it is we're talking about create tensions so that they create angles. So that at a very submicroscopic level, you'd have to use a electron microscope to be able to see it. Quartz comes in 6-sided crystals.
Oh,
And so if it's had space in nature to grow, then you can get a 6-sided large crystal out of it. So this one has this nice big one, several small ones, and lots of little ones.
wow.
This one's from Colombia down in South America.
Oh, wow.
And you can see when it was growing, it was kind of messy at the time because you see all this orangey stuff in
Yeah.
it. That's pyrite. So it grew around some pyrite that was in the vicinity when it did it.
Oh my gosh. And tell us about this one.
Well, that one is fluorite.
Wow.
Fluorite is calcium fluoride, is formula. And in Eau Glaze, Ohio, fluorite like this is found, where you see more than one color. This has 3 different colors
Yes.
of fluorite in it in one place, which is highly unusual.
Wow.
It's great and very shiny and so on, like you can see.
And that one, the outside would look
There's your rock.
so, and then you'd have to come up and chisel
well,
it, or
somebody probably cracked it
wow,
and opened
get
it
a
up.
surprise.
Yeah, a little geode.
Wow. And I don't think we've talked about this one. This is
That's
neat.
rhodochrosite.
Look at that.
That's you shouldn't touch that.
Oh,
The rhodochrosite tends to be expensive, but it's also sort of soft,
oh, okay.
so that it could easily scratch,
Oh, okay.
and so it's just better
Yes.
do it
around
like
the
this.
outside.
Now, rhodochrosite has a formula similar to calcite. Calcite is calcium carbonate. Rhodochrosite is manganese carbonate, and so they have similar structures. So this forms what we call a rhombohedron. It's in the trigonal system, and gives you crystals like that. And rhodochrosite, the color red, comes often with manganese minerals.
Wow. And the outside,
And it's just the rock
Looks
again.
just the rock.
See, it's got some pyrite in it. You can see
Right.
the glistening. Or let
Yeah.
me see, what is that? Anyway, that might be mica. Put my glasses on, I can see it.
wow. And this these little crystals kind of
That's
reminds
quartz.
me of that
Yep,
one.
it is.
Yeah.
That's the same stuff.
Like in the same family, you'd
yeah,
say?
exactly. Well, it's quartz. Yeah.
Yeah.
So, oh yeah, that's mica. So all that shiny stuff is mica. So this was a hunk of rock containing mica and quartz and rhodochrosite.
Wow. Beautiful. And I think this little guy.
Well, now that's calcite with the copper in it, remember?
Oh, that's right. That's
Yeah.
right. And this one.
All right, now this one, now let's get back to our crystal systems again.
Okay.
One of the crystal systems is cubic. A cube has got every side the same
Right.
and all right angles.
Okay.
And pyrite is a perfect example of that because we have this large cube here.
Heavy.
Now within the cubic system though, if you look at the electron microscope picture of it, you can see these spots where the loci of the particular atoms are. So pyrite's iron and sulfur, so you've got iron and sulfur scattered around in a particular way with the atomic forces. And in garnet, it's a more complicated formula. Garnet is a silicate, so it's got silica and oxygen and probably iron and aluminum and a few other things. And so in a complex way, with all the atomic forces amongst them, they form in the basic cubic system, but there's a little bit of a pull towards modifying that. So what you get here is a dodecahedron. A dodecahedron is one of the possibilities out of the cubic system. And so garnets tend to form in dodecahedra. And this is a particularly nice example of it from Austria.
Yeah. Oh.
And is in a schist kind of mica schist matrix that the garnet is in. Now, and here's some more examples. Now, in the cubic system, another possibility is to form an octahedron. So you've got
Wow.
4 sides up and 4 sides down, all these little triangles around, and that you can see is basically a cube, because here's one point, and if you fill out the rest of the lines, it'll make a cube.
Cube. Wow.
And then another weird thing that can occur in the cubic system, not very often, but in pyrite is one of its best places, you get something with 5 sides. 5 sides in nature is very unusual. So pyritohedron, we call it, so pyrite got its name here. And it's a 5-sided example, and this 5-sided all around. It's a cute little piece.
And they find it just like that?
Oh, they found it just like this. If you don't find it just like
Yes.
this, you're cheating.
Oh, okay.
Because then you're
You don't wanna
modifying it
cheat.
somehow, right?
Yeah.
So you have to watch that. That's why you look at it to see if it has all the right characteristics.
And then what about this one?
Well, that's tourmaline again. That's the same as this guy.
Oh, wow.
Except it's got slightly different formula. And so this one is called lidocotite. Well, this one is called elbaite,
Okay.
from the island of Elba by Italy. Anyway, so it's a nice colorful one. So you have the
Yeah,
green
that's
part here and
beautiful.
then the red, rosy red on top.
Wow.
Nice piece of tourmaline. Now tourmaline is trigonal, remember? So you got the triangular
Triangular.
form in here.
Yeah.
And even on the outside you can see it's kind of 3-sided.
Right.
Well, this is also 3-sided. So you got 1,
Okay,
2, and
I
3
see, I
sides.
see.
But you'll notice that each of the 3 sides has got a bump on it.
Yeah.
So it's, in a true sense, 6-sided.
Oh,
So trigonal system is really a subdivision of the hexagonal system.
wow.
So just to make things a little bit
Yeah.
more complicated,
Yes.
but again, to give you more information so you know whether you're seeing the real thing or not.
Wow. And where would you find this?
Oh, tourmaline exists all over the world again.
Wow. In Michigan?
In Michigan, the Upper Peninsula. I don't remember seeing any in the Lower Peninsula. But many, not in every state maybe, but it's not real uncommon.
Okay.
But pieces like this, real uncommon.
Wow. So are there clubs that people can get into with the mineralogy? Is there any?
Oh yeah, the Michigan Mineralogical Society. To repeat that
Okay,
again.
yeah.
We meet usually the second Monday of the month, from September through May,
Okay.
at the Cranbrook Institute of Science.
Okay.
Cranbrook is a wonderful museum in all sorts of different ways, and one of the museums they have in the Institute of Science is minerals. And so Cranbrook has one of the best mineral collections in the world on display. So if you're interested in seeing minerals, you can see lots of good ones at Cranbrook.
there.
And our meetings are at Cranbrook, as I say, 7 o'clock, the first Monday, second Monday of most months.
Wow. And so at these meetings, someone would bring maybe something new that they found?
Yes, or they might talk about a new mine that's been explored, or an old mine one they found out more about. We have talks on all sorts of different subjects. We have talks on earthquakes, we have talks on mineral formation, we have talks on everything.
Now, to go into a mine, can you go by yourself, or do you have to
Well, as I
have-
say, most times you need to be with a
You have
group.
to be-
You need to have
okay.
permission. Now, on the other hand, there are some mines which are out in the Southwest, for example, that you could just wander into, and some people do. There's a fair amount of danger involved, because an old mine, its superstructure may not be very good, may not be maintained, and so some of those logs that are holding up the walls might collapse at any time.
Oh, okay.
Or you can also meet a friendly rattlesnake or scorpion.
Okay.
Arizona is known for both.
Yes.
And it
Oh.
happens to people. But on the other hand, if
wow.
some people are careful and they go in and they know
Yeah.
their way, they do that.
And can you make money off of what you find?
Oh,
And
sure.
you can-
Oh, yeah. As a matter of fact, that's true.
Wow.
We went down to Flint Ridge, Ohio, a year ago. Now, Flint Ridge, Ohio is well known for its flint. And so there's a little mountain of flint down there that the Indians began excavating 5,000–6,000 years ago, I suppose. And that's what they made their arrowheads out of, and their axe heads, and sledge, things to break things
Breaks it,
open with, and so on. And so we went down there and we did that. Took my trusty sledgehammer and whomped on a few places, and out comes a bunch of flint. And so then we kept the ones we liked the best for ourselves and sold the others.
Wow.
I think we just about paid for the trip. So
Oh my gosh,
that worked
that's
out very
wonderful.
nicely.
Yeah.
That worked out very well.
Yeah.
But some people do a lot better than that. I mean, some people will go to mines and really bring out some good stuff and earn their living that way.
Wow.
So then that's where these dealers come from that are at our shows. A lot of them have done the mining themselves. Some of them have bought it from the miners, so it varies. You'll get different levels of that. But oh yeah, you can make money mining. And as a matter of fact, the whole mining industry, which is to bring out metals for manufacturing and things like that, as side effects of the mining industry, there are a lot of minerals found. And so that creates a little bit of conflict sometimes between the mineral collector and the miner.
Yeah.
But on the other hand, the miners have often learned that they can make money if they'll stash aside some of the better mineral specimens, because there's still plenty of ore for their mining, and they can sell the mineral specimens and do quite well. And even some large mining corporations have been cooperative and allow people to be right at the area they're working. So if there's minerals that are exposed after an explosion or after a bulldozer works on something, the mineral dealer has got the first looks.
Wow, that's
and he
exciting.
gets in there and pulls out. Yes, very. And he gets to pull out the pristine stuff that didn't get damaged, and then the rest goes to the be ore.
What about the diamond mines? Are there?
Well, no, that's a different thing. No, well, of course, you go down to Arkansas. Arkansas has a state park diamond mine, and people go there all the time and find diamonds.
Wow.
And that's quite near the surface, which is how they have a bulldozer that comes in and cleans open, scoops up some fresh areas for people to look through.
Yeah.
But I think a 3-carat diamond was found there not too long ago.
Oh,
and
wow.
happens occasionally. It's great. But most times, like in South Africa, are deep, deep beneath the surface.
Oh, okay.
And in the process of, although occasionally, that's why when the miners come up, they often get searched. Because if they find diamonds down there on their own and slip them in their pocket, that isn't good for the mining company.
Yeah.
So, but nevertheless, yeah. And the mines are very useful for studying all these things. So then in the process of digging that deep mine and going down there, you learn about how that got formed.
Yeah.
What the temperature and the pressure was, so that from that, they discovered, for example, that if you want to manufacture diamonds, you need to create a machine that will have a great amount of pressure, thousands of pounds of pressure, and temperature that will compress it, and you get your artificial diamonds.
Wow. Wow. Well, where can people go to find out more information?
Well, Michigan Mineralogical Society has a website, michmin.org.
Okay.
There's more information there. Cranbrook will have lots of potential for information
Yeah,
there.
that
Wayne
sounds
State
fun.
University, and the web.
Okay.
The internet has lots of things you can
Yeah,
look
I
up there to
bet.
get information.
I bet. Well, Stan, thank you so much. This has really been an eye-opener for me.
Great.
So, thank you.
Oh, you're welcome.
Thank you. And thank you for joining us. And we'll see you next time on Exploring Hobbies.